We crush the coal and we inject it into the furnace, and we have burners that light it on fire, and it creates a continuous fire inside. There's thousands of tubes in there filled with water. The steam is siphoned off the top at the drum and sent to the turbine, which spins and creates electricity through the generator. We run a maximum of 300 megawatts a day when the demand is high. We typically run June to early September almost non-stop. The boiler is suspended vertically from the top because the metal, based on its length and type and how hot you get it, will expand. Well, you want it to expand downward with gravity assist, because if the boiler was built from the ground up, it would be working against gravity, and we would build in stresses and get distortion in it. And it allows expansion, and it's done with a series of hangers that allow it to come back to its natural state when it cools. To demonstrate this, we set up a time-lapse camera while the unit was cold. Upon startup, you can visibly see the boiler housing moving down approximately 3.5 to 4 inches. That was near the top. At the bottom, where it was harder to access, it grows and moves over 9 inches downward. The piping that carries the feed water and the steam all have hangers on them that allow them to move up and down with the boiler. And if you were to restrain them, you would cause severe damage and possibly failure. These demands for energy goes up and down based on wind, temperature, and other factors like congestion in the system. When they want us up, there's a certain amount of time we have to have this thing ready and on. One of our measurements on how successful the power plant is our reliability. We maintain the furnace, the piping, the logic, all the major components. Our reliability number goes up, and we're called upon more often by the market. So it's important for us to monitor all these situations and react accordingly to keep the unit reliable.